today, we actually want to talk about the variants of logistic regression. Of course, you know, last week I introduced you to logistic regression. You know, the idea behind the use of logistic regression is when we are trying to model relationship between a categorical response and, you know, one or more explanatory variable. Of course, I walked you through that last week where we focus on binary logistic. The binary logistic is when there are two possible outcomes that we can, that's what make it binary. But today we want to look at some other form of logistic regression model. This time around, not binary. And that's why I'm actually calling them variants of logistic regression, ordinal versus multinomial. So in the outline, I'm going to have a quick review on binary logistic regression. Then I'm going to talk about the ordinal. Then lastly, I'm also going to talk about the multinomial. So which means these are logistic regression type model. Now, I want to have a review on binary logistic regression now. The word binary means there are two possible outcomes. It means the levels of the response is just two, either this or that. That's what we call binary. And don't forget, in binary logistic, we can have a simple binary logistic, we can have a multiple binary logistic. The simple binary logistic is when I am only considering one predictor that we also call one explanatory variable or one independent variable. And of course, the response variable is categorical. It has two levels. That's what we call simple binary logistic. What about multiple binary logistic? Look at the word binary. It means we still have two levels of the response, except that the numbers of predictor is more than one. The multiple, you know, actually talking about, we're focusing on number of explanatory variable more than one. Now, I want to go into the ordinal logistic regression now. You know, the ordinal is talking about the levels of the response variable is going to be more than two, and they are ordered. They are ordered. Ordered in the sense that the first level is maybe the least or the greatest. Okay, so we're going to order the response. We're going to order the level of the response. For instance, if you are talking about customer satisfaction, okay, in the customer satisfaction, I know you're going to have not satisfied. You're actually going to have one of the levels. It's going to be not satisfied. Okay, satisfied. Okay, very satisfied. These are levels, but these are ordered. They are ordered. Okay, so anytime your response variable is actually ordered, then we're going to use ordinal logistic. But what if in a situation where this is not what I have? If I'm talking about race, where I actually, maybe in the United States, I talk about whites, I talk about African American, I talk about Latino, and I talk about others. Okay, this is not ordinal. This is not ordered. Okay, what we're going to talk about here, we're actually going to use multinomial. The multi is talking about multi-levels. That's what it means. Does that make sense? That is a difference that we actually have between when you talk about ordinal and multinomial. Now let's take a look at this. Let's take a look at an example under the ordinal logistic regression. A researcher is interested in what factor influence medaling in Olympic swimming. Relevant predator including, okay, at training hours, diet, age, and popularity of swimming in the athlete's home country. The researcher believed that the distance between gold and silver is larger than the distance between silver and bronze. You know, in a situation where you got 3 levels, but the distance between like the award here, you know, the distance between the gold and silver is different from the distance between silver and bronze. Okay, so, and of course these are ordered because a gold has more value than silver and silver has more value than bronze. Okay, that's one example of ordinal logistic regression. Another example is study to look at factors that influence the decision of whether to apply to graduate school. College juniors are asked if they are unlikely, somewhat likely, or very likely. Those are ordered. Does that make sense? Those are ordered. Okay, to apply to graduate school. Hence, our outcome variable has 3 categories, but these 3 categories, they are ordered. Okay, and data on parental education status, okay, whether the undergraduate institution is public or private, and the current GPA is also collected. The researchers have reason to believe that the distances between these 3 points are not equal. Okay, and for example, the distance between unlikely and someone likely may be shorter than the distance between someone likely and very likely. Let me tell you this: the moment you have variables, the moment you have, variables that's actually has like 3 levels, when the response variable has 3 levels, it is not likely that the distance between 2 successive levels will be the same. It's not likely. Now, because of that, I want to walk you through this example. I'm interested in this example. Now, take a look at this now. I want to use a data set from the University of California, Los Angeles, where this is the first 6 in the data. Okay. The first applicant here to the graduate school, the data junior, okay. Of course, they are still junior. And he said, oh, when they asked him a question about whether he's going to apply to the graduate school, and he said it's very likely. Okay, PARED01, of course, we are that actually represent the education of the parents. That is our parental education status. That's what we mean. Okay, because at times whether parents actually apply to graduate school, whether before, may influence the decision of their children to also apply to graduate school or not. Then the public is also categorical. Public means whether public or private school, whether they attend public or private school. Okay, what about the GPA? Take a look at that. Now, this is a summary of the continuous predator. The only continuous predator in the data, the GPA. This is going to give us the sense of the spread. What is the minimum? What is the maximum? What is the average? What is the median? And so on like that. So like I said, we're actually going to fit an ordinal logistic regression because the levels of the response variable here is actually ordered. Now, what is the coding now? I wanted to pay attention. When we were fitting binary logistic, we use a GLM, right? GLM in a model. But when we are fitting ordinal logistic, it's going to be POLR. Do you see POLR? POLR in the code. Please take notes. POLR in the code. That's what you're going to see for the ordinal logistic. For the binary logistic, it's going to be GLM. Okay? It's going to be GLM. I want you to take note of that. Every other thing may stay the same. If you take a look at what I'm seeing now. Okay? And you don't necessarily write family equal to binomial. Okay? Because in the binary logistic, we're actually using binomial, right? Family equal to binomial. The binomial is only used when you have two possible nature. So right here, we don't have two possible nature. It's more than two, right? The levels of the response, right? And let's take a look at the results. Let me tell you this. The results under the ordinal logistic regression, we actually come in two ways. I want you to look at the two ways. If you look at the first one, that will be based on coefficients. As you can see, the parent, the PARED, the public, and the GPA. Okay. And the another one is going to come in form of the level of the response. And in the level of the response, you're basically going to see they are comparing. Take a look at this. Unlikely versus somewhat likely, and somewhat likely versus very likely. Okay. And where is the other one? Where is the unlikely and very likely? That is not going to be part of that. You know, those are the two extreme level. So the result is going to come out in this way. Now, when the result come out in this way, when you take a look at the coefficients, we got a single value for that. That's a point estimate, right? Or for the PARED, for public, and for GPA. And some of you may be wondering, what do we have in that of when we're comparing? That's an intercept. It's like we're having two different intercepts. Okay, but the slope is what you see here. Now we may want to get a confidence interval for our coefficient. Of course, you know why we're getting confidence interval, because a single value could be wrong. In statistical analysis, you know, if I really want to know how to rely on the estimate, then I need to construct a confidence interval. The confidence interval will tell us how precise is the estimate. The confidence interval will tell us how the results of the survey reflects the overall view of the general population. Now, what I'm doing here now is just the confidence interval, the same way that we did, the same code that we use in the linear regression confidence. M, where's my M? Of course, my M is what I use to save my model weight. If you take a look at what I have, now I got a confidence interval now. It's a 95% confidence interval. Do you know the next thing I want to talk about now? How do we interpret the coefficient here? For instance, the coefficient of the parent's education status, where the slope is 1.0477. How am I going to interpret that? Okay, now I'm going to say, what actually appear if you take a look at what I have here. So what I actually mean is we will say that for 1 unit increase in that particular variable, what is the 1 unit increase in categorical? If a categorical has 0, 1, right, 2 levels, the increase is going to be going from 0 to 1. Does that make sense now? And that was why I said going from 0 to 1, going from 0 to 1 maybe the parent does not have education, or maybe doesn't have a graduate education, and 1 the parent has. Okay, so going from 0 to 1, we expect 1.05 increase in the expected value of apply on the log odd scale. Like I said, don't forget the estimates here, they are on the log odd scale. And that's why we call them log odd estimates. Log odd estimates. You see that, right? Okay, so I'm actually interpreting 1.0477. When I'm interpreting that, I took it to 2 decimal. So 2 decimal is going to be 1.05. That's what you see here, increase because of positive. Now, and I'm actually going to mention this, it is not only that predictor variable that we have in the model. I also have to say, given all other variables in the model are head constants. Head constant means they are adjusted for. Does that make sense? So that statement has to reflect. Now, what about the GPA? Going back to the GPA, to 2 decimal, that would be 0.62, right? To 2 decimal. Right now you got 0.6159. To 2 decimal is 0.62. How can that be interpreted? I said, we say for 1 unit increase in GPA, we will expect a 0.62 increase in the expected value of apply in the log odd scale. Don't forget, always going to say log odd scale. Okay, given that other variables in the model are being adjusted for. Does that make sense? Now, we've been talking about the log odd. If you take a look at the confidence interval that you have, there is a confidence interval for the log odd. What if I'm interested in the odd ratio? Okay, don't forget the odd is the ratio of the probability of success to the probability of failure. What is the success in this case? The success, okay, we are actually talking about whether somebody is likely, we have 3 different kinds of opinion, levels of opinion. Okay, so we're actually going to, if I want to get the odd ratio from the log of odd, if I want to remove the log, mathematically speaking, I'm going to exponentiate. What do you see me doing? I'm exponentiating the coefficients for me to be able to get the odd. And after that, I construct the confidence interval. You know what I'm trying to tell you now? The first column, do you see the first column 2.8511, 0.9429, 1.8514? That is the odd ratio estimate. But the other one is a confidence interval associated with the odd ratio. Some of you may be wondering, why do I need the confidence interval? Okay, now I need a confidence interval in case I basically want to test an hypothesis. You know what odd ratio of 1 means? Odd ratio of 1, then the probability, the chance of the success and the failure is the same. So if you have the odd ratio of 1, that's what it means. And if 1 lies in the interval, that indicates an insignificant. Okay, if you take a look at the public now, I can say 1 lying between 0.5209 and 1.681. Why, when you take a look at the other one, 1 does not lie in the interval. Take a look at that. Now, the interpretation is very, very important. How do you interpret the odd ratio? I got the odd ratio of 2.85 the other time to 2 decimal, 2.85. How do you interpret that? You know, the 2 point, you know, when the odd ratio is greater than 1, you know what I mean? That favor what you have in the numerator against the denominator. Does that make sense? And when the odd ratio is less than 1, that favor the denominator. Now I say for students whose parents did attend college, the odds of being more likely, okay, to apply is 2.85 times than that of students whose parents did not go to college. That really makes sense, because the parents may motivate their children to go to college because they've gone to college. You get what I mean? So 2.85 times. So that is what that 2.85 actually means. But you know, I can do it in another way. You know, depending on what I put in the numerator. If I switch that, okay, then the interpretation number 2 goes, which means the same as for students whose parents did not attend college, the odds of being less likely, okay, is going to be 2.85 times. That makes sense, right? That is it. The two of them go together. Whichever way I want to interpret that, that's allowed. Okay. Now, the next thing is to talk about the school type. You know, the school type is actually categorical. Okay. Now, for students in the public school, what is the odds of being more likely? Okay. We actually said the odds of being more likely is going to be 5.71%. How do we get that? Before I first look at the odd coefficient, okay, it's 0.9429, and you're going to subtract that from 1, multiply by 100%. That will give you 5.71. And what you're going to say, that being more likely to apply is going to be 5.71% lower than that of a private school student holding all other variable constant. Whichever way you want to go, you may want to start with the public school, you may want to start with the private school. Okay, so take a look at that interpretation now. I said for students in private school, the odds of being less likely to apply, which is unlikely versus somewhat or very likely, is 5.71% lower than that of public school students holding constants or other variables. You know, it goes this way because the explanatory variable here is categorical. Okay. Now, what about the GPA? I think I've interpreted the GPA the other time. Okay. Now, if you go back to the GPA, let's see, 1.85, the odd ratio, right, to 2 decimal. Okay. And that very 1.85 going to fail for every unit increase in student GPA. The odds of being more likely to apply is multiply 1.85 times, because when I look at my GPA, when a student look at his or her GPA and realize that there's an increase, okay, that will increase the chance, right, of making an attempt to apply. Does that make sense to college? So that's what we mean. And if you want to look at it from the other way around, for every unit decrease in student GPA, you know, when I say increase in student GPA will influence the chance of applying, I can look at it from other way around. Okay, you know, when I say when the GPA increase, what about when the GPA decrease? Then the odds of being less likely, in that situation, when the GPA is going down, that particular person will be frustrated. You know, he or she may not want to consider applying for college. So it's less likely now will be multiplied by 1.85 times. Okay, ordinary constants or other variables. Okay, before I go into the next item on the agenda for today, is there any question with ordinal logistic regression before I go into multinomial? Of those of you online, can you confirm if you are hearing me clearly? Those of you online. Okay, thank you so much. Thank you for confirming that. Okay, I want to welcome you into another logistic regression type module that we call multinomial logistic regression. It's actually called multinomial logistic regression. The word multi means the levels of the response is more than 2, but they are unordered. They are not ordered. If I want to talk about race, if I want to talk about some other categorical predator variable that are not ordered and their levels is more than 2, I consider multinomial logistic regression. Okay, now I'm going to give you an example now. A biologist may be interested in food choices that alligator make. Adult alligator might have different preferences from young ones. The outcome variable here would be the type of food. Okay, the type of food, no food is greater than the other one. When you have different variety of food. Okay, that doesn't mean this type of food has more numerical advantage than the other type of food. And the predator might be the size of the alligators and other experimental variables. And this is another example. Entering high school students make choice among general program, vocational, and academic. No program has more value than the other. You get what I mean? These are not ordered. Some can choose to go for general program. Some can choose to go for vocational program. And some can choose to go for academic. Their choice might be modeled using their writing score and their social economic status. Now, I'm also going to use data set from the University of California at Los Angeles website. Okay. Now, I want to walk you through how to do this in R. Okay, we got 200 students, high school students, that are actually considering, different type of program. Okay. We're actually going to call the outcome variable prog. The prog is going to be categorical. That prog actually means the levels or the type of program we get around, the general, the vocational, the academic. And of course, the predator variables will be socioeconomic status that I'm actually going to denote it as SES. And 3-level categorical variable, that SES, that socioeconomic status, is categorical. And of course, we've got a writing score. That's another predator, and that's continuous. Now, I wanted to take note of this now. If I basically want to run this in R, if I want to do the multinomial, place I wanted to focus now. If I want to do the multinomial, if I want to run the multinomial, it's actually going to be a 2-stage process. Number 1, I need to decide out of the 3 levels of the response, I need to reference one. Like I said, it doesn't matter the level that I choose to reference. Referencing the level does not mean it's inferior to order. No, I can choose whatever to reference. Now, right here, now we're choosing academic. Do you see that code? Okay, where you see arrow level, okay, arrow E level, $M1 prog, ref, equal academic. I can also decide to ref general program. I can also ref vocational program. It doesn't really matter the one we make reference. Does that make sense to everyone? Except that if I want to interpret the other one that I did not reference, I'm actually going to do that relative to the one that I reference. I'm going to compare them, the unreferenced one with the one that I reference. Now from there, I'm going to go into the text. Oh my God, take a look at the code now. When I'm dealing with the ordinal logistic regression the other time, it was a poly R. But right now, it's going to be multinom. You see multinom? Okay. Now I'm actually going to do the multinom, the proc 2 on SES plus right that I equal to that. Let's see result. Oh my God. The result is also going to come in two different ways. The result is going to be like, I'm actually going to have for coefficients where you're going to see the general and vocation. Why is it that academic is missing here? Of course, the level of the response that is missing is the one that we reference. Don't forget the other time we reference academic. Okay. Now take a look at the other output is going to be the standard errors. We're actually going to have two different outputs. The first one is going to base on the coefficients, and the second one will be based on the standard errors. Take a look at that. Now, based on what I have now, what if examiner asks you to write the feeder model? From this output, maybe I'm looking at something like this now. Oh my God, it's looking as if this may be part of final, where I give you a model this way, and I ask you to write what is the estimated, logistic, multinomial logistic regression model. Now, take a look at what I'm going to write. Oh my God! When I'm writing the feeder model now, is basically going to be in a logit form, which is going to be the log of what? The first one is basically going to be the log of the probability for general divided by academic. The second one is going to be the log of the probability of the vocation divided by the academic. When you take a look at the two feeder model, you're basically going to see that the log actually centered on, the two level based on the one that is referenced. Take a look at that. Any question on how this feeder model work, whether in person or online? Any question? So when I got three levels, then I'm actually going to have two feeder model. Don't forget, we decided to make a particular level reference, and we're now looking at the log of the probability of, like for the first one, the general. On the one that is referenced, don't forget the academic one. Then the second one is going to be the log of the vocation program now, okay, with respect to, relatively to that of academic. And do you know that the logit here will be linearly related to the predictor variables? Take a look at that. Now, do you know, as I wrote this now, I can go back, I come back here. I can come back to the estimate. Okay, when you take a look at the first one, that will be the intercept, 2.852. That will be the intercept of the first module. 5.218 is the intercept of the second module. And when you take a look at what I have, I got two SES. Oh my God, why am I getting through socioeconomic variable? Don't forget, the socioeconomic variable is categorical. It has three levels, and one level has already been referenced as well. And the one that is referenced is going to be the low. We're talking about socioeconomic status. Going to have the low, going to have the middle, going to have the high. I'm only seeing middle and high showing in the output. R as automatically reference the low one. Does that make sense? Okay, now that I'm going to have right, take a look at that. That's continuous, right? So that is all what I'm just going to plug in the estimated, the multinomial regression, model. Of course, you know what your B10 is. Your B10 is the intercept from the first one. The B20 is the intercept from the second one. Then the B11, the B12, of course, you're going to have two slope. The B11, if you take a look at the B11 and B21, it's basically going to be the intercept that correspond to SES middle and SES high. Okay, of course, the last one that we actually call B13 and B23, that would be the slope for right. Okay, now this is interpretation now. You want to interpret the B13, right? And where is the B13 now? The B13 is 0.58. Okay, now when you take a look at the 0.58, it's negative, right? For the general, you know, if you take a look at that for the right, for the general, negative is 0.058. Okay, now how do I interpret that? I'm actually going to say a unit increase in the variable right is associated with the decrease. Why am I saying decrease? I'm actually saying decrease because of the fact that the right for general is actually negative. Take a look at that. That's a negative, right? And that was why I said a decrease. Oh my God, when I say decrease now, I have to mention of the logod. Logod of being in the general program versus the academic program. Don't forget, when I was considering the logod, it's actually the log of the ratio of the general program divided by the probability of the academic program. Take a look at that. Okay, that is how I'm actually going to interpret that. What about the B23? Okay, the B23 now. Okay, you're talking about the coefficient that correspond to vocation. That's a negative one. Okay, now when you take a look at that now, that is also going to talk about decrease. But this time around, when I say a unit increase in the variable right, it's associated with a decrease in the logod. Oh my God, don't forget to put a logod. The logod of being in the vocation program versus the academic program in the amount of that, 0.1136. Now I've walked you through how to interpret the continuous predictor. How do you interpret the categorical predictor? Or for instance, you basically want to interpret, how do you interpret this guy here? How do you interpret this guy here? The negative 1.16328. Or how do you interpret any of the value that you have in SES middle and SEXI? Okay, so in that one, okay, the log of being in the general versus the academic program will decrease by 1.163 if moving from low to high. Take a look at that. Low to high. Why am I saying low to high? Don't forget the low was the level of that categorical predictor that was a reference. Does that make sense? So whatever if I want to interpret the the estimate that correspond to the categorical predictor, I need to start from the low that was reference to whatever that you see. Does that make sense? Okay, the same thing here. I'm also going to go, I'm going to go from low to middle, low to high. Take a look at that. So I think that is the explanation of what you see. Okay, that is the interpretation. Okay, what am I doing here? If I want to, we've been working on the log or scale, but we want to remove the log. Want to back at the ratio, at the odd ratio. Of course, I'm going to exponentiate. That is the code now, ESP. When I exponentiate, everything that I have here now become a odd. We have already eliminated the log. And the way we're going to interpret will be different. Okay, like for instance, you can see for right, how can I interpret the odd value for the predictor right for general is 0.9437. I'm actually going to be talking about relative risk. Okay, what I'm relative risk, it means I'm considering the odd of one with respect to the other. Okay, the relative risk ratio for 1 unit increase in the variable right is 0.9437 for being in the general program versus the academic program. All the time, I have to, when I mention general, it has to be versus the academic program. The academic program was actually referenced. Then I'm going to do the relative risk ratio switching from SES 1 to 3. What I mean by 1, low, to 3 is going to be high, because if I want to interpret, the 3 points, I mean, 0 point, the 312C that you see here, SES high, you're actually going from low to that. Okay, and of course, you got to mention be in the general program versus the academic one. You can do the same thing for be in a vocation program for academic one. Finally, we want to have a prediction of probabilities. In a logistic regression model, whether multinomial, whether multinomial or ordinal logistic regression. Of course, there are two forms of logistic regression. We can have it in a log-odd way, which we call the logit form. We can have it in a probability way. Now here, we may actually want to predict what is a probability, of those in academic class, okay, those in the general class, those that we actually go for the academic, for general, for vocation, putting into consideration their socio-economic status. Because the socio-economic status at times could affect the kind of program you want to go for in college. Now take a look at the SES, data frame. I'm actually considering the SES, the low, the medium, the high socio-economic status. Okay. I'm putting into consideration the average of the right, the continuous predator. Now, what do I want to do? I want to predict the probability of students that we actually consider academic, general, vocation in each socio-economic class. Now, the first one, the socio-economic class 1, what do I call that? Low. In the low socio-economic class is 0.4397 of the student we consider academic program. In 0.3582 we consider general. In 0.2021 we consider vocation. I also estimate the probability for the middle class and also for the high class. I wanted to take note of that in such a way when you add the row, when you add the probability in the row, it must give you 1. Okay, so this is a code if you basically want to make a prediction of a student that we actually, the high school student that will consider the academic program. It's like we're talking about their percentage. When you multiply this probability result by 100, that will give you the percentage of the number of high school students that will prefer academic, the general program and the vocation program, putting into consideration their socio-economic status. Any question? This is where I'm actually going to stop today. Of course, on Wednesday, I'm going to continue with another variant of logistical regression. And of course, all lectures that we have left in this semester, the lecture materials have already been uploaded. I needed to check the canvas, targeting to finish all of that by Monday. Okay. And of course, I'm actually going to walk you through the practice questions, final practice questions. Then the next thing is going to be the final. Of course, the final will be very easy. I needed to go into announcement section. I've already specified the areas, the week, the final exam we cover. So check the announcement section. In the absence, of question. Make sure, or before I said make sure you stay safe, I think I'm going to say, you know, since the deadline for practical 2 is already due, then I'm actually going to release the rubric for practical 3. Of course, the practical 3 is just going to be the how you analyze the project, but I'm actually going to give you the rubric, like what you're going to follow, okay, for you to be able to do that, because I actually have the belief you have successfully imported your data into R. Okay, so I'm going to grade the practical 2 there today, and you're basically going to see all results. But let me tell you, if I'm able to see results, I mean, if I'm able to see your data, then you actually, if I search your data, of course, the grade is going to be 100%. But I only want to see your data just to be sure that you have the data that you want to use. Okay, so make sure you stay safe and have a lovely day. Bye for now, everyone.